Hey everybody, Dr. A here, and in this video we're going to be exploring an example of power transmission. So let's go ahead and get started. In the given information, we're being told that a motor can develop 4 horsepower when it turns at 160 revolutions per minute. If the allowable shear stress of the shaft material is 12 ksi, compute the smallest diameter of the shaft to the nearest 1/8 of an inch. So let's go ahead and get started. I'm going to write solution here. And I'm going to go ahead and get my constants spelled out and converted accordingly. So we're told that the power is 4 horsepower. So let's go ahead and convert this to base units. So we know the conversion from horsepower to pound-feet per second is 550, right? So we're going to say 4 HP multiplied by 550 pound-feet per second divided by 1 HP. That's the conversion factor. So we end up with 550 times 4. So we get 2,200 pound-feet per second as the power converted from horsepower, okay? Now, what about the frequency? Well, we were told that the frequency is 160 revolutions per minute. Now, the thing we've got to be careful about is notice that we have seconds in the value for power. And so we need to somehow get the per minute converted to per seconds for frequency. So I'm going to multiply this by 1 minute over 60 seconds, okay? So the minutes cancel, and if I do 160 divided by 60, I get 2.667 revolutions per second, okay? And then we were told that tau allow is 12 ksi. So again, we got to be careful here. We have 12 ksi here, and notice again back up at power, we have 2,200 pound-feet per second, okay? So we need to convert something such that we have consistent units of force and consistent units of length here. It's probably easier to convert the pound-feet per second to kip inches per second. So to do that, I'm going to take the 2,200 and I'm going to divide by 1,000. That gives me kip feet per second, right? And then I'm going to multiply by 12 inches per foot. And so I should get 26.4 kip inches per second, okay? And so if you're confused by this conversion factor, maybe pause the video or rewind it and do it yourself. But it's a pretty simple conversion factor going from pounds to kips and then feet to inches, okay? So now I've got consistent units, right? I've got KSI for tau, revolutions per second for F, and kip inches per second for P. So all my units for these 3 values that I'm going to end up using are all jiving with one another. Now what we can do is use our 2 relationships that we defined in the previous background video. One of them is that tau allow is equal to TR over J, okay? And the other is that torque can be expressed as power divided by 2 pi times frequency, okay? And so what we're going to do is we're going to substitute these values or these equations into one another strategically to solve for what we ultimately are looking for, which is the diameter of the shaft, okay? Now you might be looking at this, you might be saying, well, wait a second, diameter is not showing up anywhere in either of these equations. Well, it is because it's built into the radius and to the polar moment of inertia. So let's break this down. We're going to say tau allow is torque times, now radius we can write as diameter over 2, and then polar moment of inertia for a solid circular shaft is pi times d to the 4th over 32, okay? And so what we can do is do a little bit of algebra and consolidate these fractions, all right, and consolidate the fact that we've got a d here and a d to the fourth in the denominator. And so we do some rearranging and we'll get TD over 2 multiplied by 32 over pi d to the fourth, and we can cancel some things, okay? And so this reduces down to 16t over pi d cubed. And it reduces because, you know, the 2 cancels and the 32 becomes a 16. This d cancels and this d to the fourth becomes d cubed, okay? Now what I'm going to do is substitute this t equals p over 2 pi f into this t value right here, okay? And so in doing so, I can now say that tau allow equals 16 over pi d cubed, and then where t is, I'm going to substitute that p over 2 pi f, okay? And then what do I do from there? Well, again, I can simplify some things. This is going to simplify down to 8p over pi squared f d cubed, okay? And how do I know that? Well, you know, the 2 cancels with the 16 becomes an 8, and then the pi's combine to be pi squared, all right? And so we have this handy little formula here, tau allow equals this 8p over pi squared fd cubed. And so what we're going to do is solve for d cubed. We're going to pull this d cubed out and take a cubed root finally, okay? And so what I can do is I can say d equals 8p over pi squared f times tau allow. And then all of this is going to be cubed rooted or raised to the 1/3 power. Now, if you need to pause the video and break this down and show some more intermediate steps, that's fine, but this is just algebra. In fact, this is probably the equivalent of about 9th grade algebra, so this should not be that difficult, okay? But if you need to pause the video and work this out a little bit more detail for yourself, please go ahead and do so, all right? Now what I can do is substitute all my values in accordingly for P, for F, and for tau allow, okay? And so I'm going to go ahead and do that, and I'm going to say D equals, I'm going to open up this big bracket, I'm going to say 8, and then what was P for power? Well, earlier we did all the conversions, and we got 26.4 kip inches per second, okay? So we're going to write 26.4 kip inches per second, and then we're going to divide by pi squared, and then what is that frequency F? Well, we converted that accordingly earlier, 2.667 revolutions per second, so 2.667 revs per second. And then times tau allow, which I believe was 12 KSI, yep. So 12 KSI. And then we can bracket this off, and we raise all of this to the 1/3 power. So we can type this in our calculators very carefully. It's very easy to make a calculator mistake here if you're not careful. So I'm typing this in my calculator, again, quite carefully. And then divide by 12, and then we're going to raise it to the 1/3 power. And so I get 0.874 inches for that diameter. So what I can do is, because that's 0.874, I'm going to say use a diameter of 7/8 of an inch, which if you type 7/8 in your calculator, you'll find that that's 0.875 inches, okay? Now, why am I saying 7/8 of an inch? Well, again, the directions originally said, oops, scroll too far, said round it to the nearest 1/8 of an inch. And so what you're looking for is an answer that's based on an increment of 1/8. That's what those directions are referring to. So that concludes this example. If you found this helpful, please hit like and subscribe and be on the lookout for content like this later on. Thanks for watching.